Okay, we're going to do try to do 6 and 7 here. And 6 assumes that the data is from the recent seminar. The president thinks that additional advertising should increase attendance by 10%. So how much can they spend on advertising and achieve the same level of operating income as last year? Okay, and then we'll come back to this one after that. So these formulas are complicated, so in my mind it's always best to start with something simple and then increase the complexity from there. So operating income, about as simple as it gets, would be equal to revenue minus fixed costs minus variable costs, right? So our current operating income then would be 120x for revenue, yeah, that's our selling price, minus the fixed cost, minus variable cost, 30x, that's our variable cost. So 90 times 125, so 120 minus 30 is 90, minus 125, or times 125 people, minus fixed costs, 6750 is our current income. Okay, so what we want to know is how much more can we spend on advertising. And so if this is equal to 60, we're going to make it, there's our same earnings equal to 6750, and we're going to have that equal to our contribution margin, 90, times 135 people. So that's the original 125 plus another 10. Okay, so 90 times 135 plus 4500 times x. X is the additional plus x. Yes, that's revenue plus x. Might be minus x. We got a sign wrong here, but this is going to be the advertising right there. Maybe I went the wrong way. That's okay. So then rearrange everything, and we've got 1250. 1250 is contribution margin minus the 4500. I think this is a minus 4500 minus the advertising. Sorry, you guys. Minus the advertising, and then when you reduce it all, this is 900 is equal to x. So they can spend, what that means is they can spend another $900 on advertising. That's all they could spend, okay, if they want to try to make 6750 again like they did last year. Okay, but I think that the key with a lot of these problems is to start with something that you're sure of and start filling in the blanks, because there are shorter ways to do this, but you've got to really have these formulas in your head. Now let's look at the next one. Let's go through the facts first. This is a sales mix problem, and this IBSO is considering offering a discount to those who sign up early and a quantity discount for companies that send more than 3 attendees from the same company. So they want to boost attendance to 180, give discounts of $4 for early registration and $8 for multiple people from the same firm. And early registrants and multiple people from the same company take a lot less to process and confirm the registration, so they think they can save $5 per attendee. So our contribution margin will be higher. Well, not necessarily. The variable costs will be lower. Okay? Fixed costs are allocated based on the number of expected attendees in each group rather than being specific to each group of attendees. So fixed costs cannot be avoided if certain attendees do not participate. And here's our mix. Okay, we expect 108 regular, 54 early discount, and 18 quantity discount. So based on the sales mix data, what is the weighted average contribution margin per attendee? Okay, what's break even? All right, and what is the operating income if the projections of 180 attendees are correct and the sales mix, let's see, with the sales mix of regular, early discount, and quantity discount attendees. Okay, so you've got to keep this on the side to follow it. And we have first of all our sales mix. We've got regular, 108 regulars, right? Yeah. 54 early discount, and 18 quantity discount attendees. So that's a total of 180, which is what they wanted, right? Yeah, 180 attendees. So this is our sales mix. So what proportion are they? I would take 108 divided by 180, and I get 60%, 30% for the early discount, and 10% for the quantity discount. Okay? So now what we're going to do is figure out what our weighted average contribution margin is. So the selling price minus the variable cost is going to be equal to the contribution margin, okay, times the percent of the sales mix. So from the regular attendees, we've got a contribution margin of 54 per person, okay. For this one, for the 30%, the early discount, we get to take $4 off the selling price. They save $4 there. Our variable cost goes down by $5, and now it's 25. So this equals 91, and we've got 30%. That's worth 30% of our sales mix, or 29.3. Okay, of our 27.3. Sorry, of our contribution. Kind of ran out of room here. And then 10% is the sales mix. So now we take another $4 off for the early discount. 112 minus 25 gives us 87. It's a 7. And we expect 10% to be quantity discount people. So that's 8.7 of contribution margin. So for the whole bundle, I added up, and my weighted average contribution margin is 90. Okay? So first the sales mix that was given to us, then we figure out the sales mix percentage, and then selling price minus variable cost equals our contribution margin times the percentage that it contributes to the whole. Okay, so that's 90%. So my fixed costs are $4,500 divided by a 90 contribution margin. That's what this is. Gives us a break even of 50 units. Okay, so when we sell 50 of the combinations, okay, of this, that's when the company will break even. And then the last one is well, how much money are we going to make if they, where is it? What is the operating income if the projections of 180 attendees are correct and the sales mix, the quantities mix stays the same? So I've got fixed cost plus my operating income, that's what this is, divided by my weighted average contribution margin, is to equal 180 attendees. So this is a rearranged formula, okay? Maybe I should take it apart. 4,500 plus X equals the contribution margin times 180 people. I think this one's easier to see, isn't it? For me it is, okay? And when you reduce it all down, your income is $11,700. Okay, I think we need to do more sales mix problems though besides these. Maybe a couple more of several types here. Okay,